Hello everyone, good morning. Today we will start with the very interesting topic of disk structures of module 6. This is very easy and very much interesting to understand the concepts and very much scoring too. Now before going on with, first we understand the structure of a disk. A disk looks somewhat like this. Actually this thing that you are seeing is a CD drive only. I have taken photo intentionally so that you can visualize something. This is the back part of your CD and this is the front part of your CD. If you might have seen, this is the general things you might have seen. Yes. Now this disc are arranged concentrically one over the other by a spindle, and there is an arm onto the top and bottom of every disc. And a disc, or we can say actually platter, disc is actually an arrangement, a horizontal, a vertical arrangement of concentric disc, and whereas this thing which I am making you see is a single disc only, which consists of concentric circles. This my diagram is not good, but it is enough for you to understand concentric circles, and these circles are called as tracks, and every track consists of sectors. This consists of sectors, and such type of disc are concentrically arranged one over the other. I have, for you to understand, I have taken a photo. You can see over here, taken a photo using a pen, this which acts as a spindle. This one is a spindle in between, and this disc which I have shown, I have taken two discs for you to see. And since it is taken by phone, the color of the disc is like this due to the light of the camera coming. And there is a head, read write head, this one, this which I taken by, I have by holding a tongs over here. This read write head, it will move like this only, this read write head, and this read write head is one on the top and one below. That's why you can see over here, one is below a disc and one is top of the disc, and both the surface, the top and the bottom of this particular platter is covered by a magnetic material. The dimensions and the particular specification are all there given in the lecture notes also. Even I will be talking about it. And this arm which you are seeing now, this arm is the top and the bottom one. This one is connected to this read write head is connected to a arm, like that. So if you have four discs, like this is one, and this one and this two. If you have two discs, means you have four read write head. And if you have 8 discs, you are having 16 read write head. So understand, I hope you are understanding this thing very well. So for your understanding part only, I have taken this photo like this. You can see this is an arrangement of a disc, and one single thing is called as a platter. Very important, this platter. So let's move ahead. So that's all about the disc. Let's see the specification. Diameter range from 1.8 to 2.25 inches. Both surface covered by magnetic material. Both surfaces are covered by a magnetic material. Read write is allocated to disc arm. Both the surface covered with magnetic. Read write head is allocated to a disc arm. Surface of the disc is divided into circular tracks. Tracks are further divided into sectors. That's what I told. Now there are few parameters which you need to take care while studying disc scheduling. The few parameters which govern disc scheduling. First one is the seek time, disc scheduling, the rotational latency, and transfer time. Also disk access time, disk response time too. And we will take up about all these things. Seek time is the time required to move the read write head to the desired location. As we have seen, the read write head moves from in this way only, the whole disk about. So the time required to seek means to seek that particular place from it where it has to access, that is called as seek time. Suppose if the read write head is at a place 10 and it has to come to 75 over here, it has to access this particular location called 75. The time taken to come from this location to this location, that's called as See, then this is a physical work. Remember, my dear, this is a physical work, physical movement that takes place by using this read write head, which is connected to an arm. To read write head, top and beneath. Next is disk scheduling. In case of multiple IO requests coming from a system, there needs to be some scheduling algorithm which decides which request must be executed first or which request must be right now given time for execution. Rotational latency. Now we have seen one thing, that in this disk about the head, read write head moves in this way, and this thing moves in this disk moves rotationally. The disk moves rotates, sorry, the disk rotates, and the read write head moves in this way. So if I want to access, and these are my sectors, suppose for example, let me say these are my sectors, these are my tracks, sorry, and currently I am in a track called 10. I think this is not visible. Suppose I am in a track called 10 and I want to access a track called 70. Now since the disk maybe the read write head currently is over here, this first track. Now this read write head will take only these movements, this straight line movements, so it will come to this track first, it will come to this track, and the disk will rotate, in, and the 70, this particular location will come be down this head, and the location will be accessed. So that rotational latency, rotation takes place and then it will access, so that time required for that rotation, that is includes your rotational latency. Now next is transfer time, time taken to transfer the data, and data from your disk to your to the device which you want to transfer. Depends on the rotational speed of the disk and number of bytes to be transferred. Obviously, if you have to transfer so many number of bytes, much amount of bytes, it will time required will be more, and also on the location from where it is. If it is too far from the head, if it is, then it will take more time, and if it is near, it will take less time, maybe depends on the scheduling algorithm used. This is very important, dear students. Disk access time is equal to seek time plus rotational latency plus transfer time. Again, seek time, rotational latency plus transfer time. We have seen already what is seek time, what is rotational latency, and the transfer time. Seek time, time taken by the read write head to come to the particular track which it wants to access. This is for the particular sector when it has to reach, that is called when it reaches, that is rotational, and the transfer time is the time taken for the data to move. So the disk response time spent by the request, like when it comes, when the first request comes and when it is given the first time for IO operation, that is called disk response. Actually it is the average value always taken for a response time. For a request, if we say, it is the average response time which we get actually. Now in short, there is one diagram, like we can, very easy for you to understand. Your disk has all these parameters: disk delay, queuing delay, seek time, rotational latency, and transfer time. This disk access time which you are seeing, this disk access time is actually total of all these three components. Keep it in your mind, this thing. Whereas the disk response time, if we say, then it is disk delay and queuing also added along with your disk access time. We can also say in this way, disk response time is equal to disk access time plus queuing delay plus disk delay. That's all for today related to your disk structures. So in short, we shall conclude. Today we learnt about a structure of a disk, the various parameters which govern the scheduling of a disk. The parameters are seek time, transfer time, rotational latency, queuing, disk delay. We also learnt about the structure of a disk, how it looks, what are its dimension and all. We will look on to the schedule algorithm in the coming lecture. By that time, stay home, stay safe, keep learning, be happy. Have a nice day ahead.